Hello, everyone. Today we're going to be dealing with 9.5, which is irrational numbers. Last lesson we dealt with rational numbers. So irrational numbers are numbers that are not rational. An irrational number cannot be written as a fraction, a over b, where a and b are integers and b cannot equal 0. Some other irrational numbers, a square root that has a whole number that is not a perfect square is irrational. A cube root that is not a perfect cube is also an irrational number. Another example of an irrational number is pi. And then remember from the last lesson, irrational numbers are also decimals that do not terminate or end, and they do not repeat. So if we look down here, we have a little diagram of real numbers. Real numbers make up both rational and irrational numbers. On the left, we have different types of rational numbers. And then here on the right in blue, we have irrational numbers. So here are some just different examples. Again, 7 is the cube root of 7 is irrational because 7 is not a perfect cube. The square root of 2 is an irrational number because 2 is not a perfect square. Pi is another example of an irrational number. And then, like I said, decimals that do not terminate, do not have any type of pattern, do not repeat, these are also irrational as well. So the first thing we want to do is be able to classify each type of real number. So the first one, we have the square root of 12. And that is, 12 is not a perfect square, so it is irrational. So if you put the square root of 12 in your calculator, you'd get a decimal that does not terminate and does not repeat. So it is irrational. Now, if we're looking at negative 0.25 repeating, that's a repeating decimal. So that's what makes it rational. Because it repeats, it's rational. Negative square root of 9 is equal to negative 3. Negative 3 is an integer, therefore it is a rational number. The cube root of 15. 15 is not a perfect cube, so if you put the cube root of 15 in your calculator, you're going to get a non-repeating, non-terminating decimal, so that's what makes it irrational. And then, like I said, pi, if you actually look at what pi is, it does not terminate, it does not repeat, so pi is an irrational number as well. So the first step is to know, is to be able to determine, is it rational or irrational. Next, we want to be able to approximate. So like, what is the square root of 71? We know it's going to be some sort of repeating decimal, but how can we kind of estimate or approximate what it's actually worth? So we're going to make tables of perfect squares. So like the 7 squared is 49, 8 squared is 64, 9 squared 81, and so on. So if we're looking at 71, 71 falls in between 64 and 81. Because 71 is closer to 64 than 81, the square root of 71 is closer to 8 than 9. So if we put it on a number line, it would be in between 8 and 9, a little bit closer to 8. So square root of 71 is approximately 8, somewhere between 8 and 9. So we're going to do the same thing. Make a table of numbers between 8 and 9 whose squares are close to 71. So 8.3 squared is 68.89, 8.4 squared is 70.56, 8.5 squared is 72.25, and 8.6 squared is 73.96. Because 71 is closer to 70.56 than it is to 72.25, the square root of 71 is closer to 8.4 than it is to 8.5. So again, we found out which whole number is it close to, and then we figure out, okay, let's figure out what tenth is it close to. And then once we're able to do that, then we can compare two different types of irrational numbers. So let's see what happens. We're going to approximate the square root of 35. So 5 squared is 25, 6 squared is 36, 35 is pretty close to 36, so we're going to say the square root of 35 is almost 6. So there it is on the number line. And then we're going to do the same, the cube root of 80. So notice that 80 is between 4 thirds, which is 64, and 5 to the third, which is 125. Because 80 is closer to 64 than to 125, we're going to say it's